All right, hey there, everyone. Welcome back. Let's look at classifying and plotting complex numbers. There's a few problems that were troublesome here. It wasn't so bad. It seems like we kind of got it again. Let's look at the ones that were the most troublesome. The first one was a problem like this. What type of number is 3 minus 719 times I? Okay, now when we talk about complex numbers, we kind of break it down into two pieces, you may remember. We have this, a complex number comes in the form of a plus b times I. Every single complex number looks like this. And the reason why is because we take this square root of -1, it's I, it's a variable, we've kind of turned it into this variable, this letter. It becomes its own separate thing. So like while this looks like it's two numbers, this is actually one number. In the same way that 3 plus 4 equals 7. 3 plus 4, that's actually one number. We just haven't reduced it down yet. A plus BI is also one number. We just haven't reduced it down yet because we don't know how. We don't know how to combine 3 and, for example, 3 minus 719I. We don't know how to combine that. We don't know how to put that together. There's no way to squash them together that we know of yet. So while it is just one number, it's an unsimplified number, and we don't know how to simplify it. Cool. So a complex number has two parts to it. It has the part that we're used to, just a normal number. We call this the real part because it's just the normal, it's on the real number line. I can graph any number that I can place there. And then we have b times I. This is the part that we can't really work with so well. It's kind of difficult. We call this the imaginary part. So these two parts together make up a complex number. And everything can be written a complex number. If I wanted to take the number, say, like 5, we could say 5 plus 0i. That's technically a complex number because I could write 5 plus nothing times I. Well, 0 times I is just 0, so it'd be 5 plus 0, which is 5. So 5 is technically a complex number. If I said 3i, that's technically a complex number because I can write it as 0 plus 3i. That's just 3i. I can write it as a form of something plus something times I. So everything is technically a complex number. I just have to write it in that fancy form. Okay. So let's see what this problem they give us. They give us a plus a. They gave us an a plus a b I. So it has a real part. It has an imaginary part. So that would mean it's a complex number. So our answer would be complex. Okay, great. The next, and that's all it is really for classifying. The rest is all about plotting these complex numbers. Let's look at some examples of plotting numbers in the complex plane. I'll grab some axes here. Now this is a really, really neat thing. We took some time and we really developed this. And I'd love to explain more of this to you. Maybe I'll give you a link to something that can really help explain what's going on here. This can be rather, but it's really, really neat how this works. And I hope you take the time to look into it when I share that link. I think it will. I'll show you that link, and it was really, really nice because this is such a useful tool that I is not really a number that we just can't work with entirely because we work with it all the time. And so calling it imaginary is kind of not really helpful. It's more of like another dimension of a number. And so what we're doing here is looking at the dimensions of this number. Looking at a two-dimensional number at the moment. So -5 minus I. When we talk about the number line, we're so used to the number line looking like, well, just a line. Left to right, we can plot numbers. Left to right, we can plot -2 would be here, and then 3 would be here. So we can plot the numbers in the number line pretty easily. And so if we have a number like -7 in the number line, that's exactly what we'd expect it to be. We would go graph these axes, and we'd go 1, 2, 3, 4, 5, 6, 7, and we'd graph -7. And that's the number. Now, when we get to a complex number, it just adds an extra element to this. So there's the x-axis, there's the real axis. And then we're going to add an imaginary axis to really graph this BI part. So this is the A part that we graph. The BI, or just BI part, we graph that on this imaginary axis. So we'd say this is I, this is 2I, this is 3I, this is 4I, and so on. Okay. So when we graph -5 minus I, we'd go -5 on the line, on the real line, A line, -1, -2, -3, -4, -5. Okay, and we go -I on the I line, which used to be the y-axis. Go -I. So the way it's placed to intersect is right here. -5, -I, that is our point, and we're good. Okay, -7, we've kind of already covered that. Really, the only difference now is that we have a complex axis, but it looks exactly the same. You just go -7, you go 7 back, and you've got the graph. That's it. -3i is similar as well. So instead of having a real part, there's no real part. There's just the imaginary part, or this second BI part. And so to graph the BI part, we go 0 on the real axis, because there's nothing real here, and we go down that -3i. So this is normally I, 2i, 3i. Now we're going to have -I, -2i, -3i. So -3i would be right here, and we graph that and be done. Cool.